Indirect truth tables, section 6.5. You're going to like indirect truth tables because they are a shortcut. Sometimes you can have an argument that's got 5 simple components in it, right? Well, that's a 32-line truth table. And I'm not going to do that to you. I'm going to give you at most 8-line truth tables. But so fortunately, there's a shortcut way of looking at an argument and doing a lot of times just a one line. In one line, you can determine if the argument's invalid, and at most, sometimes for some arguments, you'll have to do 3 lines, and I'll show you how that works in another video. But how do we do truth tables? I've got some steps here on this handout here, and let me go ahead and read these, and then I'll give you an example. What you do is step 1 here. If you want to test an argument for validity using the indirect method. Okay, so here what we're doing, it's a method to test if an argument's valid or invalid. What you do is you assume the argument's invalid. Now how do you do that? You basically write out a line under the main operators of every premise, make all the premises true, and make the conclusion false. Remember when we were doing truth tables? You had an argument, you did a whole big truth table, then you looked for a line where the premises were true and the conclusion was false, right? Well, that showed you the argument was invalid. It was a bad argument or a bad skeleton. So we're doing the same thing here. We're just starting out with a line with true premises and a false conclusion. Then step 2 here is, I'm sorry, after you, and the way you do that, after you've written out true premises, you put a true under the main operator of each premise and a false under the main operator of the conclusion. Then, and that actually is step 3, you work backwards and assign values. And if you start with this invalid line, and I'm going to call an invalid line here for our purposes, let's see, a bad line, okay? It's a bad line. If you have an argument and you start with a bad line and you work backwards and you're able to fill in all the values, it means you have a bad argument. I'm a bad argument, so that's why when you started with a bad line, I didn't mind. I tolerated it. Okay? Because remember, if you have a good valid argument, you mean the skeleton is valid, it's a good skeleton. There's no way with a good skeleton that has true premises that it's ever going to deliver you a false conclusion. So if you're working backwards here and you can assign values and there is no problem, it means it's an invalid argument that tolerated a bad line, an invalid line. If you work backwards and there's a problem, something's gone wrong, something should be true but it says it's false, or something should be false, it says it's true, there's a problem, then the argument is valid. It's kind of turned around. A contradiction or a problem means the argument's valid. If everything works, it means the argument's invalid. So you kind of got to be aware of these little twists and turns. Things are kind of intuitively reversed here a little bit. Let me reiterate what I just told you by reading this paragraph. I think it'll help. Okay, if you can work backwards, and you're going to see what I mean by working backwards in a minute, without coming up with an incorrect truth value, a contradiction is what the book calls it, or I'm calling it something's gone wrong. If you can do that, then this is revealing that it is possible for this argument to have true premises and a false conclusion, which shows that the argument is invalid. On the other hand, if you can come up with a contradiction, an incorrect truth value as you work backwards, then this means that the argument is valid. Because as soon as something has gone wrong, it is revealing that it is not possible with the particular argument at hand to have true premises and a false conclusion, which is how a valid deductive argument is defined. Okay? So here's some rules to think about. We're starting with a bad line, right? Okay, starting with a bad line, which means true premises and a false conclusion. That's what I'm calling a bad line. The book says start with an invalid line. If you have no contradiction, if you can fill it in backwards, no problem, it means it's an invalid argument. And the argument, in a sense, is speaking to you. I'm an invalid argument, I'm a bad argument, and that's why I was able to tolerate the bad line you started with. However, if you start with this invalid, bad line, and you work backwards, and there is a problem, and you'll see what I mean by a problem soon, then the argument is invalid. So here, when you encounter a problem with the original bad line, it means the argument's valid. Because it's a good argument, a good skeleton, it's not going to like an invalid or a bad line. You remember, a good argument, if you did a truth table for it, one way you know it's a good argument is you never can find a line with true premises and a false conclusion. Okay, so with that, if we go to the second page here, I've got a couple examples. See these here on the second page of the handout? I have already written those out on this handout. Actually, this one, I didn't write it out. So let's write these out. This first example here, let me change my ink to black. Okay, so the first one is, if not A, then either B or C. That's the first premise. The second premise is not B, double slash, conclusion is if C, then A. Okay? Now remember, you will make the conclusion false, make the premises under the main operator true. This is premise 2, right? Over here is premise 1. The main operator for this premise is the horseshoe, and we're going to make that true. So here's your invalid line. We purposely made the premises true and the conclusion false, right? Okay, now you'd be surprised what you can come up with here. We're going to start working backwards, okay? We're going to go backwards. And for a conditional to be false, the antecedent has to be true, the conclusion has to be false, right? So C has to be true, and A has to be false. And you work backwards and you keep trying to make it work. If there's going to be a problem, you resist it and go somewhere else to see if it works. So here, for not B, the premise to be true, what does B have to be? B has to be false. So we know B is false, so let's duplicate that here. We already know that C is true, so let's make this true. We already know that A is false, so we'll make that false. Now if A is false, not A is true. Cross that out. Either B or C for a disjunction is going to make the disjunction true. So we have not A is the P. We have true, horseshoe, true, right? And that's fine because true, true for a conditional in your textbook, you know the definition of the operators. It's in the flap of your book in the back. It's also in chapter 6. So true, true, the conditional's true. This worked. If B is false, not B is true. And here, all the values made the conclusion false. The point is, everything was just fine. So, no problem, right? No problem with the initial bad line. So, invalid argument, okay? The argument is invalid, and the reason is, remember, well, I'm a bad argument. I have a bad skeleton. I'm invalid. And so when you started with a true, true, false line in this particular argument, everything filled in just fine, just as if you did a big truth table for this, you would have found this line in the truth table because I'm a bad argument. So remember, it's kind of counterintuitive, but if you can work backwards and there's no problem and it all fits, invalid argument. Okay, let's go to a second example here. Okay. If A, then either B or C, slash, if B, then D is the second, and this is on the handouts for this video. You'll see this is exactly a second example I would have done in class. Third premise is just A, and your conclusion is if not C, then D. Okay, and right here, this is premise 1, right? This is premise 2. And this is premise 3, and this right here is your conclusion. Let me just double check. If not A, B, or C. If B, then D, A. All right. Okay. Let's purposely make the conclusion false under the main operator. This premise will be true. This premise will be true. This premise will be true. And let me go ahead and outline those in green here. Okay, so true, 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 false. So there's our bad line. There's our invalid line. And now let's just work backwards and put in values. Okay, D has to be false. Not C has to be true. So this means C is going to be false. So we know D is false. C is false. A, we already know it's true. Okay, now this is interesting. D is false, so we'll put that there. We even know what B is because B cannot be true. If we made B true here, true false would make this conditional false. You know, if you go to your chart in the back of the book or in chapter 6 for a conditional, if you have P is true and Q is false, the conditional is false. So remember, you want to make it work and only reach a problem if you're backed into a corner. We're not backed into a corner here. So is there a way to make this still stay true? Yes. Make B false. So you see right there, we didn't know what B was from over here, but we know B has to be false to make this premise true. So now we can fill in the rest. B is false. C over here we already know is false. A is true. Okay, so we've got true for A. Either B or C, if they're both false, that means this conditional, this disjunction, I'm sorry, the Q, this is if P then Q, this Q is a disjunction, and with two falses the disjunction is false. But look, we have true, false for a conditional. That's false, but here it says it's true. So we have a problem right here. A problem. Okay, now you know what we mean by that. A contradiction. Okay, a contradiction. Okay, and so this is valid. Remember again, fourth time I'm saying it's counterintuitive. We have a problem, but it means it's valid. And the reason is, I'm good. So I did not tolerate a bad line. Okay? A bad line. All right, and I know hopefully it doesn't sound silly. I'm personalizing the arguments. I'm calling a line bad because hopefully this can help, because this gets a little reversed and twisted. It's not very counterintuitive. If it works with a bad line, it's invalid. If there's a problem with the bad line, it's valid. Okay, so I'm just really actually, if we go back here, I'm trying to make sure that you understand. And this gets ingrained in your head right here. These rules you have to keep in mind. Okay, we're going to stop there, and then on part 2 of this, I'm going to show you when there are times when you're going to have to use indirect truth table with 3 lines. You remember I said a lot of them you can deal with 1 line? You're going to have some that you will have to use at most 3 lines, so that'll be coming up next. And then we'll talk about using truth tables to determine if statements, not arguments, but statements, are consistent or not.